Assalamualaikum, my name is Muhammad Ashmi. I'm from Group 7. Today I will present Lab 5, which is Ohm'S Law. My group mates is Taslim Kumar and Muhammad Shakir Farhan. Okay, objective for this lab is to investigate the relationship between voltage, current intensity and resistance, and also to determine the resistance of unknown resistor arrangements. Okay, for part A, we visit the FASTA website and we drew the circuit as shown in figure 2 on the website, and we set the Rx to 100 ohm, and the input voltage was set as figure 3, which is 3 volt. SW was clicked to close the switch, so the switch is clicked to close the switch, and we run the simulation, and the current intensity value is recorded from the emitter measurement result, and the input voltage rise up from 3 volt up to 12 volt as in table 1, and measured current intensity is recorded. Next, we set the input voltage to 10 volt, and the resistance value changed as in table 2, and the current intensity was measured. And lastly, all the measured current intensity was recorded in table 2. So for the result of part A, as we can see here, the resistance is stay 100 ohm. We set the resistance to 100 ohm, and we increase the voltage up to 12 volt, and as we can see, the current intensity is also increased. And for table 2, we set the voltage to 10 volt, and we set the resistance increase from 68 ohm until 10,000 ohm, and as we can see, the result of current intensity is decreased. Okay, for part B, this circuit was set in the website, and this X was the resistor arrangement as shown in figure 5, which is this, and we set the voltage to 12 volt, and the switch was closed, and the current intensity was recorded. So the same procedure 1 and 2 was done to find the resistance value of Rx in figure 5, and the current intensity was measured and recorded for each combination. So basically, we change the resistor into this resistor arrangement one by one. So we can see the result for part B. For the resistance arrangement that has one resistor, the total resistance is 100 ohm, and the current intensity measured is 85.714 milliampere, and the result of 1 over current intensity is 0.012. And second, for the two resistor series arrangement, the total resistance is 200 ohm, the current intensity is 15 milliampere, and 1 over current intensity is 0.02 milliampere. The next one, for the two parallel series combination and one series resistor, the total of resistance is 150 ohm, and the current intensity measured is 63.158 milliampere, and 1 over current intensity is 0.016 milliampere. The next one, for the two parallel resistor and two series resistor combination, the total resistance is 250 ohm, and the current intensity measured is 41.379 ohm, 41.379 milliampere, and 1 over current intensity is 0.024 milliampere. And the next one, for the three series resistor arrangement, the total resistance is 300 ohm, the current intensity is 35.294 milliampere, and 1 over current intensity is 0.08. And for the last one, for the 4 series resistor arrangements, the total resistance is 400 ohm, the current intensity is 27.273 milliampere, and 1 over current intensity is 0.037 milliampere. Okay, for the question 1, basically it's asks the relationship between voltage, current intensity, resistance and current intensity. So the answer is the relationship between voltage, current and resistance is described by Ohm's law, which is this equation I equal to V voltage of current equal to voltage over resistance tells us that the current I flowing through a circuit is directly proportional to the voltage and inversely proportional to the resistance. For question number 2, it basically asks us to describe the relationship of theoretical values for resistance, voltage and current electricity in mathematical and written form. So the answer is based from the Ohm's law. To find a value for voltage in a circuit, we must multiply the current with resistor, V equal to IR. Meanwhile, to find the value of the current, we must divide the voltage with resistor, I equal to V over R. And lastly, to find the value of resistor, we need to divide the value of voltage with current, R equal to V over I. And for question number 3, we plot a graph by using Excel of voltage versus current electricity for both experimental and theoretical results. So for the first one, the graph of voltage and current electricity, we get a directly proportional graph. As the current electricity increase, the voltage also increase. Sorry, I missed. As the voltage increase, the current electricity is also increase. Okay, for question number 4, using diagram, we determine the values for current electricity at a voltage 2, 5 and 7.2 volt. And as we can see, the graph that we get is also directly proportional, which is as the voltage increase, the current electricity is also increased. And we determine the value of current electricity at the voltage of 2, 5 and 7.2 volt, which is at the voltage of 2 volt, we get 20 milliampere, and at the voltage of 5 volt, we get 50 milliampere, and at 7.2 volt, we get 70 milliampere. And for the last question, question number 5, we calculate the resistance value of a lamp, which 4 volt divided by 0.04 ampere, and the formula is R equal to V over I, and we get the answer, which is R equal to 100 ohm. For question B, what voltage is applied to a 1 kilo ohm resistor when a current of 18 milliampere flows through it, and we use the formula V equal to IR, and we get the result, which is 18 volt. And for question C, how high is the current intensity flowing through a resistance wire of 200 ohm when a voltage of 8 volt is applied? So we use the formula I equal to V over R, and we get the answer of 0.04 ampere. And for the conclusion is, we can conclude that Ohm's law deals with the relationship between voltage and current in an ideal conductor, and this relationship states that the potential difference across an ideal conductor is proportional to the current through it.